Now that you've got some idea of the four forces on an aircraft, let's you and I talk about what actually creates the lift that makes an airplane fly. And we can refer back to a guy named Bernoulli, whom I'm told was Swiss, and he did some experiments with moving fluids. And by the way, air is a fluid, so everything that Bernoulli did with water applies to air. And what he did was force water through a narrow point in a tube, and by the way, a narrow point in a tube is called a venturi. And he put some gauges in here and he measured the pressure as it went through this narrow point. And now what he found is what I think are really fascinating things when he did this. Bernoulli found that when the fluid got to a narrow point, it had to speed up. And the interesting thing is that Bernoulli found that at points where the fluid is going the fastest, the pressure is the least. Now, if we remove one half of the venturi and take it away, what we're going to find is now that we have the shape of an airplane wing, and you'll find exactly the same thing occurs on an airplane wing. When the air is going over the top of the wing and it gets forced out of the way, it resists compression and speeds up. And by the way, you should know that if you put air in a gallon jug and squeeze it, you can compress it. But free air is incompressible. So if you force it out of the way, when it flows over the wing, it doesn't compress at all. What it does is speed up to get out of the way. And Bernoulli's law says, and here's the trick, Bernoulli's law says that at places where the air is going the fastest over the top of the wing or the curved part of the wing, the pressure is less. So over the top of an airplane, what you really have is low pressure up here over the top of the wing and relatively high pressure underneath the wing. And it's that pressure differential that creates lift, and that's what makes an airplane fly. You have lower pressure over the top of the wing and higher pressure underneath the wing. And that pressure differential will occur anytime the air is flowing smoothly over the surface of the wing and conforming to the surface of the wing.